Welcome to Breaking News to Trading Moves. $34 billion. That is, OpenAI's reported projected capital expenditure for just a single 12-month period in 2025. To put that raw number in perspective for you, $34 billion is more than the entire gross domestic product of Iceland. It is a staggering amount of capital, and it's being spent purely on expanding computing capacity, building entirely new models, and preparing the books for a possible initial public offering.
Yeah.
Today, we are tracking exactly whose pockets that money is flowing into.
Yeah, it's a massive, just an aggressive allocation of capital.
Right.
When a single private entity commits to spending $34 billion, that money doesn't just disappear into the ether. It physically moves out of their accounts and, directly onto the balance sheets of other companies across the technology sector.
And we're going to break down exactly what that means for you. We know the stated reasons for the spending, like $19 billion of that total is allocated straight to research and development.
Wow, $19 billion.
Yeah, and nearly $6 billion is going directly to sales and marketing. So our mission today is to follow that cash. We're going to look at the mechanical realities of the market to clearly identify the winners and the losers. Let's start with the immediate beneficiaries: hardware, cloud, and infrastructure.
Well, to spend that much capital, you can't just hire a few thousand more software engineers.
No, obviously not.
Right. A massive portion of this money must physically flow into the actual hardware and the facilities required to run these AI models.
Which brings us to the first group of winners.
Yeah.
AI chips and custom silicon. We hear about processing chips constantly, but let's talk about the exact mechanism here.
Okay.
Why do advanced AI models require such an enormous amount of physical processing power in the first place? When you use a chatbot on your phone, it feels entirely weightless.
It feels weightless on your phone because the heavy lifting is happening in a data center thousands of miles away. It all comes down to, the mechanics of how the mathematical calculations are performed.
Okay, break that down for me.
Sure. So traditional computer processors are designed to handle tasks sequentially. Think of a traditional processor like one incredibly fast chef in a kitchen.
One fast chef. Okay.
Right. They can make 100 burgers very quickly, but they still make them one at a time, moving from one task to the next.
Okay, sequential processing.
Exactly. But artificial intelligence requires parallel processing. To predict the next word in a complex sentence, or to generate a photorealistic image from a text prompt, the system must perform millions of calculations at the exact same moment.
Millions?
Yeah. So instead of one fast chef, you need 100 chefs working simultaneously to assemble a single meal.
That makes sense.
And that requires a highly specialized physical architecture, specifically what we call accelerators.
And when we talk about providing those specialized accelerators, Nvidia, ticker NVDA, remains the undisputed leading supplier. They essentially built the physical architecture that handles this parallel processing better than anyone else.
Oh, they absolutely dominate that space. But because the demand from companies like OpenAI is so intense, corporate buyers are constantly seeking alternatives to avoid supply bottlenecks.
Because no company wants to be totally dependent on a single hardware vendor.
Exactly. That puts advanced micro devices, ticker AMD, in a prime position as the primary alternative for these highly specific AI workloads.
Then you have a company like Broadcom, ticker AVGO. They operate a bit differently.
Yeah, they do.
They gain from the demand for custom AI chips, but they also specialize in the networking technology for these massive computing clusters. Let's talk about why networking is such a critical bottleneck.
This is a fascinating mechanical problem. You can't just plug 10,000 highly advanced processors into a wall and expect them to function as a single brain.
Right, they have to talk to each other.
Exactly. These larger computing clusters require wildly complex networking technology to ensure all those individual processors can communicate with each other instantly.
Because if they don't,
if you have a $40,000 processor sitting idle for even a few milliseconds waiting on data from another processor across the room, the entire cluster slows down, and you are just burning cash.
Wow.
So Broadcom builds the specialized traffic lights and highways that remove those communication bottlenecks.
That makes perfect sense. So that covers the physical silicon.
Oh.
But OpenAI needs far more computing capacity than it can physically build and manage on its own.
Oh, without a doubt.
It takes years to secure land permits, pour concrete, and build a functioning data center. So they have to lease that capacity. This brings us to cloud and AI infrastructure providers.
Correct. Oracle, ticker ORCL, is a clear beneficiary of this dynamic. They are landing major AI contracts, which includes the massive Stargate build-out.
Right.
Oracle has aggressively positioned itself over the last few years to offer the raw computing infrastructure that AI developers need right now.
We also have Amazon, ticker AMZN, gaining through their Amazon Web Services division. They already possess the global data center footprint.
They too.
But then you have a slightly different player, a company like CoreWeave, ticker CRWV. They offer a very concentrated way to trade this rising demand for graphic processing units. Why would a company use CoreWeave instead of just defaulting to Amazon?
Well, CoreWeave is a compelling business model because they don't try to be everything to everyone.
Okay.
Amazon Web Services offers millions of different enterprise tools, database management, website hosting, legacy enterprise support.
Right, the whole package.
Exactly. CoreWeave strips all of that away. They focus strictly on renting out raw, specialized compute power specifically for AI.
I see.
If you are training a model, you might not want an entire IT department in the cloud. You just want the absolute most powerful engine available. CoreWeave gives you exactly that.
Let's transition to the physical reality of these data center operations.
Yes.
Because when we say the cloud, it sounds invisible and ethereal.
Yeah, like it's just floating up there.
Exactly. But the reality is highly industrial. What does an AI data center actually look like on the inside?
It is intensely industrial. AI servers are incredibly dense. They use substantially more electricity and produce an extraordinary amount of heat compared to conventional legacy servers.
How much heat are we talking about?
To put it simply, standard air conditioning literally cannot move fast enough to pull the thermal energy off an AI processor before the metal melts down.
Wow, before the metal melts, which creates a rising demand for an entirely different set of companies. Arista Networks, ticker ANET, supplies the high-speed networking equipment for these facilities.
Right.
Vertiv, ticker VRT, provides the specialized cooling and power management systems. And Eaton, ticker ETN, supplies the heavy electrical distribution equipment.
How does Vertiv actually solve that heat problem you just mentioned?
So Vertiv is critical because they provide advanced liquid cooling systems.
Liquid cooling.
Yeah, instead of just blowing cold air across a room, these systems pipe liquid coolant directly to the hot physical components on the server rack.
That sounds intense.
It's essentially heavy plumbing designed for supercomputers. And what about Eaton? What does electrical distribution actually entail at this scale?
Well, you can't just plug an AI data center into the local municipal power grid.
Right, you'd blow a fuse for the whole city.
Exactly. The voltage requirements are massive, so Eaton supplies the massive industrial transformers required to step down that raw voltage safely.
Right.
They provide the switchgear that prevents catastrophic electrical fires and the uninterruptible power supplies that keep the servers running if the main grid blinks.
Let me offer an analogy to clarify this whole ecosystem for you, the listener.
Sure.
Think of this $34 billion AI build-out like constructing a brand new city grid from scratch.
Okay, a city grid?
Before you can ever sell the houses, which would be the software in this scenario, you need the concrete, which are the processors from Nvidia and AMD. You need the raw land to build on, which is the cloud computing capacity from Oracle and Amazon.
Yep.
And you absolutely need the utilities, the liquid cooling and power management from Vertiv and Eaton. The $34 billion is paying to build the city grid.
Exactly. And to take your city grid analogy one step further, right now we're in the land grab phase.
The land grab phase.
Yeah, the companies pouring the concrete and laying the electrical wires are getting paid today, regardless of whether anyone actually buys the houses tomorrow.
Right.
The hardware and infrastructure companies profit from the sheer act of building. But the software companies, the ones trying to eventually sell those houses, they face a very harsh, immediate reality.
Wait, if all this hardware is being bought, someone has to be buying it to build competing software.
Precisely.
That puts smaller software companies in a terrifying position. Let's look at the other side of this spending. The losers, or at least the companies facing intense, immediate pressure. This starts with smaller AI software companies staring directly at OpenAI's $19 billion research budget.
It is a staggering competitive disadvantage.
I can imagine.
I mean, if you're a small and AI company, OpenAI can simply outspend you to improve their foundational models faster. They can afford to dramatically lower their subscription prices, enter entirely new markets, and spend aggressively on marketing just to win the exact same enterprise customers you are targeting.
We are looking at companies like C3.ai, ticker AI, SoundHound AI, ticker SOUN, and BigBear.ai, ticker BBAI.
Exactly.
Mechanically, how do they even operate in an environment where the market leader is spending the GDP of a small country?
Well, to survive, they have to abandon the idea of competing on general intelligence.
They just can't do it.
No, a startup cannot build a better general-purpose chatbot than OpenAI. It is mathematically impossible with their budget disparity.
Right.
So instead, they must focus on highly specialist areas where general models struggle.
Okay.
Furthermore, to satisfy the market, they must show strong recurring revenue and improving profit margins. But most importantly, they must prove they possess defensible technology.
Define defensible technology in this specific context. You mean a product that a massive competitor cannot easily replicate and give away for free?
Precisely. Defensible means relying on proprietary data that OpenAI cannot just scrape from the public internet.
Ah, I see.
Think of a highly specific medical diagnostic tool trained on private, encrypted hospital records.
Or like a compliance engine specifically built for international maritime law.
Yes, perfect example. These are niches where specialized, legally protected training data is much harder to acquire than raw computing power.
Okay, I understand the direct threat to the small startups, but what about the established legacy software providers?
You mean the giants?
Yeah, Adobe, Salesforce, Intuit. These companies have dominated their respective sectors for decades.
Well, the raw capabilities of these expanding AI models put severe pressure on companies selling specialized tools at premium prices.
How so?
If a large language model can perform a workflow that used to require a premium specialized software license, the pricing power of that software company completely evaporates.
Adobe, ticker ADBE, is facing this directly with generative image and video tools.
Absolutely.
When a marketing user can generate a highly produced promotional video in seconds using a simple text prompt, the demand for complex premium video editing software changes drastically.
It really does.
And then you have Intuit, ticker INTU, which handles corporate bookkeeping and tax work. How exactly does an AI replace an accountant's workflow?
Well, at its core, bookkeeping is basically data categorization and strict rule following.
Right.
You take a receipt, you identify what it is, and you assign it to the correct tax code. Large language models are basically pattern recognition engines.
So they're perfect for that.
They excel at exactly those tasks.
Yeah.
An AI doesn't get tired, it doesn't make transcription errors at 2 in the morning, and it can process thousands of invoices in the time it takes a human to open a spreadsheet.
Wow.
So Intuit could see a substantial portion of their core accounting work fully automated by general models.
And then there is Salesforce, ticker CRM. They are rapidly integrating their own AI agents into their platforms, but they have to justify that integration to their enterprise customers.
Exactly. Salesforce must prove to their massive enterprise clients that their new AI agents actually create new measurable revenue.
Right.
They can't just slap an AI assistant onto their dashboard and charge an extra 20% fee if that tool merely adds costs without generating tangible financial returns for the client.
Okay, I have to push back on this narrative a bit. The concept of the margin squeeze.
Okay, let's hear it.
Do established companies like Salesforce and Intuit possess a protective moat because of their deeply embedded customer relationships and their decades of proprietary data?
That's a fair point.
Or does OpenAI's raw spending power entirely negate that advantage? I mean, ripping out a legacy Salesforce integration is a nightmare for any corporate IT department. You can't just do that on a Tuesday.
No, it is a critical question, and you're right to point it out. They absolutely possess a moat.
Okay.
The threat here is not immediate total replacement tomorrow. The threat is exactly what you called it, margin squeeze.
Right.
The moat keeps the enterprise customer from leaving today because the switching costs are too high. But the rapid advancement of general AI puts a very hard ceiling on what Salesforce or Intuit can charge for premium features moving forward.
Because the alternative is getting so cheap.
Yes, those premium add-ons become baseline commodities. Consequently, these legacy companies are forced to spend billions of dollars on their own internal research just to maintain their current market position.
Which severely eats into their long-term profitability.
Exactly.
So that financial pressure bleeds directly out of the software product market and straight into the human labor market. Specifically, the technology consulting services required to actually implement, maintain, and test all of this new enterprise technology.
Yeah, the entire technology consulting industry is heavily reliant on the billable hour.
Writing custom code, testing software updates, integrating new applications across global departments.
Historically, it takes thousands of human hours, and those hours are billed directly, minute by minute, to the corporate client.
Which brings us to technology consulting firms like Accenture, ticker ACN, EPAM Systems, ticker EPAM, and Globant, ticker GLOB. Walk me through the mechanics of how AI disrupts that specific business model.
The dynamic here is a pure math problem.
Okay.
Coding agents and automated workflows are becoming remarkably efficient at specific tasks. Let's say a junior software developer at one of these firms historically took 4 hours to write and test a standard block of integration code.
Okay, 4 hours.
Using an advanced AI assistant, that exact same task might now take 45 minutes.
Wow.
This directly reduces the total billable hours needed for development, testing, and basic tech support.
Let's define the business reality of that. In consulting, there is a metric called the utilization rate, which is essentially the percentage of a worker's time that is actively billed to a client.
Right, the golden metric.
If your entire business model relies on keeping your developers billing 40 hours a week, and an AI tool cuts the time required to do the job by 80%, that worker's utilization rate plummets.
It falls off a cliff.
Pricing models break down instantly, and the firm is forced into hiring freezes.
That is the exact mechanical breakdown. To survive this reality, these massive consulting agencies must execute a very difficult pivot.
What kind of pivot?
Well, they can't sell basic technical implementation at a premium price point anymore.
Right.
Accenture, EPAM, and Globant have to move aggressively toward higher value advisory roles. They must position themselves to help executive boards adopt AI at a strategic, structural level, rather than just charging by the hour to write the underlying code.
But regarding that traditional consulting model, if a firm historically bills by the hour, but an automated workflow completes a previously 10-hour task in seconds, how do these consulting firms justify their pricing to clients moving forward?
They can't.
They can't.
They cannot justify it using an hourly model ever again. The transition is incredibly painful. They have to move entirely to value-based pricing.
Value-based pricing.
Right. This means charging for the final business outcome rather than the time spent executing it.
Give me a concrete example of what value-based pricing looks like in practice.
Sure. Imagine a massive retail client wants to optimize their global shipping logistics. The old model, the consulting firm, assigns 50 developers to the project for 6 months and bills $10 million in hourly wages.
Right.
The new model, the consulting firm, uses highly advanced AI agents to map the supply chain and finishes the project in 3 weeks.
So they can't bill $10 million anymore.
Exactly. They can no longer bill $10 million in hours. Instead, they must say to the client, our solution will save your company $100 million in shipping costs this year, and our fee is a 10% cut of those savings.
Wow, okay.
That is value-based pricing. But making that operational transition across a company with hundreds of thousands of employees is a monumental undertaking.
That makes the mechanical reality very clear. Let's synthesize all of this information. We started with a staggering $34 billion projected expenditure from a single company.
A massive amount of capital.
Let's distill this down into a clear market landscape for you, the listener, trying to figure out what this means for the broader technology sector.
Well, the market divide is completely clear right now. There is a hard line.
Okay.
Companies selling the physical tools needed to build AI, the custom chips, the raw cloud infrastructure, the high-speed networking cables, the liquid cooling equipment, they benefit immediately, regardless of which specific AI model ultimately wins the software race.
Right.
Whether OpenAI, a massive competitor, or a small startup builds the absolute best language model next year, they all have to buy computing power and electrical distribution equipment from the same suppliers.
So the tool sellers are the clear, immediate winners of this capital surge.
Yes. Conversely, companies whose software products or human labor hours can be replaced or wildly accelerated by AI face an ongoing existential challenge.
They really do.
They must continuously prove to the market that they still offer a durable, protected value that a large language model cannot easily replicate for a fraction of the cost.
We have mapped out exactly where the money is physically flowing and who stands to gain or lose, based purely on the structural mechanics of these numbers.
Definitely.
To close this out, I want to leave you with a final thought to ponder on your own. If a single dominant entity must spend $34 billion in one single year merely to expand their physical capacity, develop new models, and stay competitive, what does that mean for the barrier to entry for the next generation of technology startups?
Right.
How does a brilliant team of engineers in a garage even attempt to break into an industry where the baseline cover charge is tens of billions of dollars.
That is the multi-billion-dollar question moving forward.
This is not financial advice or buy or sell recommendations. This is purely the opinion of the author.